Welcome students. I hope you are all well. This is the fourth lecture on graph theory. Hope you have seen the previous 3 lectures. It helps you to understand this lecture. Let us start with the definition of isolated vertex. In a graph, if a vertex has no incident edges, is called isolated vertex. In this graph, V6 and V7 are isolated vertex and the rest vertices are not isolated. Also note that a vertex of 0 degree is always an isolated vertex. Now look at the definition of pendant end vertex. In a graph, every vertex of 1 degree is called pendant vertex. In this graph, V3 is a pendant vertex and the rest vertices are not pendant. Now, we analyze some examples. In this graph, V4 and V5 are isolated vertex. V3 and V7 are pendant vertex. V2, V3, V6 and V7 are odd vertices. V1, V4 and V5 are even vertices. It is simple graph. It has no parallel edges. It has no loops. It is not a regular graph. It is not a null graph. In this graph, V6 is the only isolated vertex. V3 and V7 are pendant vertex. V2, V3, V4 and V7 are odd vertices. V1, V5 and V6 are even vertices. It is not a simple graph. It has parallel edges E4 and E7. It has a loop E3. It is not a regular graph. It is not a null graph. In this graph, V1 to V7, all the vertices are isolated vertices. It has no pendant vertices. It has no odd vertex. V1 to V7, all the vertices are even vertices. It is a simple graph. It has no parallel edges. It has no loops. It is a regular graph. It is a null graph. Thank you for watching this video. You can note down these definitions. If you have any query regarding this explanation, you can write down in the comments section.